last term is reached in this direction only, like we have reached like this only, we can't reach like this, or we can't reach like this, and it's t minus 2, right? So we have just one option, t plus 1 to k. So last term t minus 1 has been initialized over here, t minus 1 has been initialized, these things will be 0, like dash, these things will be dashes or infinity or anything. This has been initialized as 1, as you can see, and others are has been like 0 or suppose dashes, as in the alpha case. Others has been 0, these things are 0 or dashes for all the r greater than 1. For first r is equal to 1, we are just initializing that with this, and here L is starting from 1, they are taking to k. In vector b also 1, or we can take from 0 to k also, or anything, like for suppose as per the example as we are taking vector b, and here we are just initializing as 1. And now for t minus 2, that is this thing, this is t minus 1, if we start t is equal to 0, that's fine. And then this is t minus 2. What happens is like beta of t comma k is nothing but k is equal to k minus 1. So k minus 1 to 1, k minus 1 means from here, first this what we are doing is beta of t plus 1, this thing, comma k. So we have this only, we don't have this, because with this value only this can be combined backward, because from here we can go here, from here we can't go here, like that. So in backward algorithm we have the value of this, that to find the value of this only is valid, because we can go from here to here itself. So this value computation is helpful to find the value in beta, or value of beta. This can be computed, and again these things are not computed because we need to come from back, and this value is not computed, this is 0 itself. So these values are not able to like they are not worth for calculating this beta. Again, only one step we need to take, weight is 1 unit weight only, no particular priority is given, same weights, no priority that much. So either it can come from here or it can come from here, but it can't come from here because from here we can't go here in the forward propagation. So in backward algorithm computing of beta, this thing is only useful, just this thing is only useful to value that. So that's why we are given t plus 1 to k for just this case. This is like last thing, L is equal to k, because for example L starts from 1 to k, we can take L is equal to 0 to k also, but we are just more sticking to this than this. So at last we need to do this thing, and for all other k minus 1, like for here we can just use this thing, that is nothing but beta t plus 1 r plus 1, this is t plus 1 r plus 1, we can take that, or beta t plus 1 r. To compute this t plus 1 r, we can take the other cell, like we can just move, if for example if we are over here, we can just take this beta or this beta, that's what they are trying to say. If we are over here, t plus 1 r, this will be 0, so we should not use infinity here, we have to use 0, so that like these values can be done. And for this we are not we can use this or this, but we should use this only, because from this we can't go over here, right? In forward propagation we can just go till here, so this value will be useful over here instead of this. So that we have done over here backward algo. And then what happens is like whole thing, like alpha we have calculated, and this will be remaining, that we have joint probability for st plus 1 elements. So that we will calculate like alpha we have did, like assuming that st is equal to sr we have assumed, then st plus 1 can be sr, or it can be sr plus 1, right? And then st plus 1 for is equal to sr, we will find one thing, plus st plus 1 probability we will find, and then plus we will find one probability where st plus 1 is equal to sr plus 1. And then again in the first one where st is equal to sr, in that st plus 1 is equal to sr, in that we will get st plus 2 can be sr, or SR plus 1, and in other case where ST plus 1 is equal to SR plus 1, there we will get is like ST plus 2 can be SR plus 1 or SR plus 2, like all that thing which we did in alpha over here. Like if it ST is equal to SR, we will divide this thing into two parts. ST is equal to SR, ST minus 1 is equal to SR, and ST minus 1 is equal to SR minus 1. Then again ST minus 2 we have find it can be SR or SR minus 1. Here it can be SR minus 1, SR minus 2. Like the same thing we will do for like ST is equal to SR, then we will find for ST plus 1 is equal to SR or SR plus 1. Then again ST plus 2, what we will find based on, as we have said previously, the posterior probability now is turns out to be alpha TR, beta TR. Beta values we have just found it over here, that we will substitute, and if simplify we will get the results like this, right? If we further simplification using alpha hat, which we are done, so that simplification of divergence or derivatives will be easy, then we will find the derivation or derivatives, so that all these values will be properly channelized or properly optimized using the loss function like CTC loss and using optimizers. And again all the weights, this is a cell and this is the input, so input weights, and this is output, right? So output weights will be there, all those will be updated in the RNN, like base RNN LSTM or bidirectional LSTM, using that base RNN plus LSTM, which whose knowledge is required to construct bidirectional LSTM. So those weights will be updated, like all the neural network parameters will be updated. So yeah, that's how it is. Now want to like I will just show you that beta notation, everything, how those things will happen. So here I just want to show that beta thing, like beta t comma r is like p of st plus 1 to sn minus 1 given x, like how alpha derivation we have done, like that only we need to do. And this thing will be s of t plus 1 to till sn plus 1, that is like mapping to sr plus 2 sk, right? Now we will do the further derivation. So then like solving that we will get like this, t plus 1 to sn minus 1